morning, everybody. Last Friday, we learned the third form of linear equations in two variables. That's the point slope form, right? Let's look at the formula for point slope form. In this equation, x and y are the two variables. X and y are the two variables. Constant m is the slope of the straight line. x1, y1 is any given point on the straight line. So if we have the slope and a given point on the line, then the line is determined. We are able to write the equation for the straight line. This formula is the point slope form of the equation, linear equation in two variables. Today we plan to work on three examples. Those three examples are very classical or typical examples about the straight line. And we're going to take time to work on the three problems. Let's look at the first example. When write an equation of the line satisfying the given condition, recall the relationships among slopes of parallel lines. Through 6, 5, parallel to 5x minus y equals 9. All right, let's see. We are looking for a straight line L. We know the line L passes through a given point, 6, 5. And we also know straight line L is parallel to 5x minus y equals 9. So that's what we have in the problem. Those are the information we have from the requirement. We are looking for the straight line L. So we are looking for straight line L satisfying the following two conditions. Number one, the line passes 6, 5. Number two, the line is parallel to 5x minus y equals 9. Okay, so we are looking for equation for L. We are looking for equation for the straight line L. We are looking for a linear equation in two variables corresponds to the straight line L. Let's recall how many forms so far we have learned for linear equations in two variables. If you look at the board, you look at it here. So far we have learned three forms for linear equations in two variables, right? The first form, standard form. Second form, slope-intercept form. Third form, point slope form. And we cover point slope form last Friday. We are looking for straight line L. The line satisfies the given two conditions. Passes through 6, 5, parallel to 5x minus y equals 9. So we are looking for the equation for L. What do you think? Which form is more convenient for us? Which form should we look for? Should we find the equation in standard form or slope-intercept form or point slope form? Standard point slope form. So if we have slope and y-intercept of the line, slope-intercept form is more convenient, right? Most convenient. If we know a point and slope, would that be something natural? We should look for the point slope form of the equation. What do you think? Yes? Yes or no? Do you see what I'm talking about here? No? Okay. So if we have a given point and slope of a straight line, then we can use the point slope form. to represent the equation of the line, right? Do we have a point already? Yes, we have a point already. About the slope of the line, even we don't know the value, but the second condition is related to the slope. Because L is parallel to 5x minus y equals 9. Does that mean the slope of L is the same with the slope of 5x minus y equals 9? Look at the theorem we learned the other day. If two straight lines are parallel, then they have the identical slopes, right? Their slopes are equal to each other. Does that make sense? Yeah. The two conditions. The first condition, we know a point. Second condition, we can find the slope for the line. Even it's not given directly, but we can work on it to get a value for slope, right? So point and slope, we are looking for the line. Would that be natural to find the point and slope form of the straight line? Yes or no? Am I clear? Okay, very good. So that's the idea for this problem. We are going to find the point and slope form for the line, okay? We are going to find the point and slope form for the line. If the point is given directly, the point is given directly. About the slope, we need to do something. Since the line L we are looking for is parallel to 5x minus y equals 9. Since the two straight lines are parallel, their slope of L should be equal to slope of 5x minus y equals 9, the given straight line, right? Yeah, because they are parallel, they have the same slopes. Then slope of L equal to slope of 5x minus y equals 9. Yeah, we need to find the slope for this equation. Yeah, we need to find the slope for this equation. Tell me what form this equation is in. Standard form, point and slope form, slope intercept form. 5x minus y equals 9. Huh? What is it? Standard form, exactly. Standard form is ax plus by equals c, right? Standard form, exactly. Okay, so if we have the line in the standard form, do we have a method to find the slope for the line? We learned a formula last week to get a slope for the equation if the equation is in the standard form, right? Do you guys remember the formula? The formula for slope. Yeah, if the equation of the line is in the standard form, ax plus by equals c, then the slope equals negative a over b. We practiced a few problems, right? Okay, we are looking for the slope for the equation 5x minus y equals 9, which is in the standard form. Okay, tell me what is A? A is the coefficient of x, 5. What is B? B is the coefficient of y. What is it? Huh? Negative 1, okay. What is A over B? A over B. Yeah, what is it? Okay, very good. Then the slope, which is the negative quotient of A and B, would be positive 5, right? The opposite. Do you guys remember that? Do you guys remember that? Last week. Yeah, if we have the equation of the line in the standard form, then the formula negative A over B can give us the slope. We identify A, B, find the quotient of A and B, and then take the opposite, right? We will have the slope. Since the line 5x minus y equals 9 has a slope 5, then the slope of the line we are looking for also has a slope 5, right? Yes? Okay, very good. Let's see what we have right now. We have a point 6, 5. We have a slope 5, right? So we have x1, y1. equals 6, 5. And we have slope m equals 5. We have the given point at 6, 5 as x sub 1, y sub 1. Slope of the line, we just got the value, is 5. Then by the point slope form, since we have a point, we have slope, right? That'll be very convenient for us to apply point slope form. The formula for point slope form is y minus y1 equals n times parentheses x minus x sub 1. Should we just plug in x1, y1, and m and the equation? Okay, let's see. So we copy y, copy minus. What is y sub 1? Very good. Copy equal sign. What is m? Slope m is also 5. Copy it. Copy parentheses. Inside the parentheses, we have x minus x sub 1. What's the value of x sub 1? 6, right? Here we go. That's the equation. Okay? That's the equation of the line. Passes through 6, 5 and parallel to 5x minus y equals 9. Let's make a summary. Since we have a given point on the line, and we are able to find the value of the slope of the line by using the theorem. The theorem tells us if two straight lines are parallel, then they have the same slopes. Once we have the point and slope found, we apply the point slope form of the equation to find the equation of the straight line, right? Okay, next up, I'm gonna add one more part for this example. I want you to rewrite the equation in the slope intercept form. Yeah. So what if I add one more part? Yeah. We have the equation found already. But I want you to write the equation in the slope intercept form. Yeah. The formula for slope intercept form is y equals mx plus b. Variable y is isolated on the left of the equation. Okay. Give you a couple minutes. Please work on it on your own first. The equation highlighted in yellow, y minus 5 equals 5 times parentheses x minus 6 is the equation we are looking for in point slope form. You guys need to rewrite it in the slope intercept form. Rewrite it in the slope intercept form. In the slope intercept form, variable y is isolated on the left. If you solve the equation for y, you would have the equation in the slope intercept form. So you are going to isolate the y on the left. Isolate the y on the left. The equation we have is y minus 5 equals 5 parentheses x minus 6. We want to isolate the y on the left. Can you firstly apply this reducible property to get rid of this parentheses? And then move this -5 over. Do you do that? Any progress? Where do you get a 10x? You add 5 with 30, right? 5 and 5x cannot be combined. Yes. You could only combine like terms. If they are not like terms, can you distribute first? 5 times x, 5 times -6. We'll remove the parentheses first. What is it? You remove the parentheses by applying the distributable property first. You are adding 5, right? -30 plus 5. -25. Very good. How do you distribute? You use the coefficient to multiply each single term in parentheses. 5 times x is 5x. 5 times -6 is -30, right? Very good. It's -30, +5. Let's distribute. On the right-hand side of the equation, coefficient of the parentheses is 5. Distributive property tells us we can multiply the coefficient by each single term in the parentheses. 5 times x, 5x. 5 times -6, -30, right? And then we want to get rid of the -5 from the left-hand side. We can add 5 to both sides. They cancel each other. So we have a y isolated on the left. On the right-hand side, we bring down 5x. -30 and the +5 add up to -25, right? You see that? Yeah, so that's the equation we are looking for in the slope-intercept form. Sometimes the problem requires you to find an equation in a specific form, then you have to do that. We got the point-slope form earlier. If the problem requires you to find an equation in the standard form or slope-intercept form, then you have to convert. Any question about this problem? Especially, how did we find the slope for the equation? Since the equation is parallel to the given equation, they have the same slope, right? And we use the formula -a/b, find the slope for the equation. Then we have the slope for the straight line we are looking for. Any question about this problem? You will have something like that in the test, the coming test 3. If not, let's move to example 2. Example 2 is similar but different. Some parts are very similar. In example 2, we are also looking for a straight line. The line satisfies 2 conditions. Condition 1, the line passes through given point -3, 6. The second condition, the line is perpendicular to a given equation x plus 3y equals 21. Very similar with previous example, right? In previous example, we are looking for the line passes through a given point and parallel to a given equation. Now we know we need to find a line which passes through a given point and perpendicular to a given equation. So the only difference here is the perpendicular part. Let's see, how do we process this problem? We have a point on the line already, right? We have a point on the line already. We need to find the slope for the line. Then we have a point, we have a slope, then we can use the point-slope form. In order to find the slope for the line, we need to find the slope for x plus 3y equals 21, right? Yes? Yeah. Two straight lines are perpendicular. Two straight lines are perpendicular, then their slopes multiply to -1. Okay? All right. Let's see. So every time you get a problem, you need to read the problem, make sense of the conditions, and knowing what you're looking for, and then find a path or idea to to reach the goal. Since L is perpendicular to x plus 3y equals 21, the slope of L multiplied by slope of x plus 3y equals 21 should be equal to -1, right? Okay. Let's see, what's the slope of x plus 3y equals 21? We're going to do that here. For x plus 3y equals 21, we need to find the slope for it. Tell me what form this equation is in. Standard form, point slope form, or slope intercept form? Standard form, right? Okay. How do we find the slope for the equation, which is in the standard form? What did we do earlier? Do we use the formula on the board, negative a over b? Tell me please, what is a? What is b? What is a over b? What's the opposite of a over b? Huh? -1 over 3. Opposite. Two numbers are opposite, means they have the same absolute value. The numerical part is the same. The signs are opposite. Okay, so we found the slope of the given straight line, which is a -1 over 3. So we know slope of L, the slope we're looking for, multiplied by -1 over 3 would be equal to -1, right? How do you solve for slope of L in this case? You want to isolate slope of L on the left, right? You want to isolate that on the left because we are looking for slope of L, right? Tell me what's the coefficient of slope of L? What's the coefficient of slope of L? On the left of the equation, we actually have this number multiplied by slope of L, right? So do you see -1 over 3 actually is the coefficient of slope of L? Yes, Angela? Do you see that? Okay. Remember, I made you to write out a sentence when we were in chapter 2. When the coefficient of the variable, slope of L actually is our unknown, our variable, is a fraction. Instead of dividing the coefficient, we multiply each side of the equation by the reciprocal of the coefficient. Remember that? Yeah, you have that sentence in your note, okay? Tell me what's the reciprocal of -1 over 3? What's the reciprocal of -1 over 3? -3, yeah. So we are going to multiply each side of the equation by -3. Multiply here by -3. Multiply here by -3, right? And -3 and -1 over 3, since they are reciprocal of each other, they multiply to 1, right? So we have slope of L isolated on the left. On the right, we have a -1 times -3. What's -1 times -3? What's -1 times -3? positive 3. Here we go. We got a slope for the equation we are looking for, right? So do you see that? Yeah, let me explain the result in a different way. Since the slope of the given straight line is negative 1 over 3, line L, which is the line we're looking for, is perpendicular to the given equation, given straight line. So then the slope of L should be the negative reciprocal of negative 1 over 3, right? So let's think about what is the negative reciprocal of negative 1 over 3. So for negative 1 over 3, firstly, we take the opposite. So negative becomes positive, right? And then we take the reciprocal, we flip it. So we got a positive 3, right? So that's how do we find the slope for the line L. Since we have the point, so far we have the point, which is x1, y1, negative 3, 6. We also have the slope, which is 3. Then we can use the point-slope form to find the equation of the straight line. Let me write down the point-slope form of the equation. Y minus y sub 1 equals m times parentheses x minus x sub 1, right? Let's plug in. Copy y, copy minus. Tell me what is the value of y sub 1? What is y sub 1? Negative 3? Y sub 1. Y sub 1, yeah, the second component. Y coordinate of the given point. What is it? Yeah, 6. Very good. Copy equal. What's value of m? That is 3 for sure, right? Copy the parentheses. Inside the parentheses, we copy x, copy minus. What's x sub 1? X sub 1. What's x sub 1? Negative 3, so we minus negative 3, right? Minus negative 3, okay. Inside the parentheses in the point-slope form, we have x minus negative 3. Is x minus negative 3 the same with x plus 3? Yes? Okay, very good. So I'm going to also ask you to do the same thing for this problem. Rewrite the equation in the slope intercept form. Okay? Yeah, I want you to work on this. We got the equation in the point-slope form. I want you to solve the equation for y. Isolate y on the left-hand side of the equation to get point-slope form. Sorry, slope-intercept form of the equation. Take your time. Same with earlier. You distribute, remove the parentheses on the right first, and then move 96 over. Combine like terms. Let me know what you have. The 3 examples we do today are applications of point-slope form. If you have a given point and the slope of the equation, it would be very convenient to apply point-slope form to find the equation for the line. See what you have. Distribute first, right? Very good. Practice makes perfect. Why do you have negative? So the second time is a lot faster than earlier. Yeah. So 3 times 3 is a positive 9, right? 3 times x, 3x. 3 times 3 is a positive 9, right? You don't have a negative 9. Okay, perfect. So this is only the second time you do the same thing. If you repeat the same thing like 10 times, you'll be very good at it. Distribute 3 times x, 3x. 3 times 3, positive 9. You need to have a reason for each step. This step we applied distributive property. We use the coefficient of the parentheses to multiply each single term in the parentheses. 3 times x, 3x. 3 times 3 is 9. You do not have a negative 3 there, right? You have a positive 9. And then you plus 6 to both sides. You end up with y equals 3x plus 15. That's the slope-intercept form of the line we're looking for. Yeah? Yeah. Any question about this problem? Very similar, but different, right? In this case, the line we are looking for is perpendicular to the given straight line. We applied the second part of the theorem we learned. If two straight lines are perpendicular, then their slopes multiply to -1. All right, let's see the third example. Example 3. Write an equation of a line using 2 points. So we didn't learn point-to-point form, right? Our book only have 3 forms. Let's see, how do we find the equation of a line which passes through 2 given points? So here we have 2 given points. One is -2, 5. The other is 3, 4. We know 2 different points determine a straight line. 2 different points determine a line. 2 different points are enough for us to find the equation, right? But we don't really have a point-to-point form. We have a point-to-slope form. We have slope-intercept form. Then we might have to, find out what method do you think is more convenient for this? We are looking for the equation for L, right? And we need to think about which form of the line L we're looking for. It's better, more convenient to look for standard form, or more convenient to look for slope-intercept form or point-slope form. Among 3 forms, 2 of them have slope in it, right? You see that? So slope is a very important property for a straight line. Are we able to find the slope for the line? Are we able to find the slope for the line? Huh? Are we able to find the slope for the line? Yes. This formula we learned, right? Yeah, if we know 2 different points on the line, we can use this formula to find the slope of the line, correct? All right. I would ask you to do that. Yeah, use the formula. Remember, I give you 3 steps for applying the formula. First, label the 2 points. I did it for you already. x1, y1, x2, y2. It doesn't hurt to write the values for them. To write x sub 1 is -2, y sub 1 is +5, x sub 2 is 3, y sub 2 is 4, right? Only takes you like a few seconds, a couple of seconds. And then you copy the formula. Formula m equals y sub 2 minus y sub 1 all over x2 minus x sub 1. Step 3, plug in. Yeah, I'm gonna leave the step 3 for you. Please work on it. Find the slope for the line. Plug in the 4 values in the formula. You know, when I solve this kind of problem, I would always use parentheses first. I did emphasize this is important, right? Yeah, please do the same thing. Use the parentheses first. Use parentheses to hold the places of 4 variables, and then plug in the values. Let me know what you have. Four minus 5. Yeah, exactly. Very good. Good job. Tell me, please, what's y sub 2? What's y sub 1? What's x sub 2? What's x sub 1? Yeah. This is easy, right? Everybody can do that. You just copy the formula, which is on the board, and then use the parentheses to hold the places for those variables, and then plug in the values. What's 4 minus 5? What's 3 minus negative 2? Minus negative is a plus positive, right? 3 plus 2, 5. Yeah, the slope is negative 1/5. Very good. All right, so this is just part of the problem. The goal of the problem is to find the equation of the line. Yeah, we have a slope right now. So far we have the slope of the line, and then we have 2 different points. We have 2 different points. So do you think it is also convenient to apply point slope form on the equation here? Yeah, we have a slope, we have 2 points, right? Yeah, so we are going to apply point slope form. Point slope form of the equation. The equation is y minus y sub 1 equals m times x minus x sub 1. M is the slope. We got a value for m, which is a negative 1 over 5. And what is x sub 1, y sub 1? X sub 1, y sub 1 is just any given point on the line, right? You can use this one for sure. By the way, do you think I can use this? Could I use 3, 4 as well? Yes or no? Again, in point slope form of a straight line, the point could be any given point on the line. If we can use this point, negative 2, 5, to get the equation, we could also use the second point, 3, 4, to get the same equation. Do you see what I'm talking about here? Okay, so you can, of course, use x1, y1 here, right? But if you use 3, 4, it will be also okay. Just to let you know that. For us, how about let's just use x sub 1, y sub 1, because we already label we already labeled x1 is -2, y sub 1 is 5, m is -1 over 5. 1 over 5. Okay, let's plug in. We copy 1, copy minus. What is y sub 1? What is y sub 1? Y sub 1. Yeah, thank you. Copy equal. Copy m. What's m? You guys found the slope is -1 over 5, right? Very good. Copy parentheses. Inside the parentheses, copy x, copy minus. What is x of 1? -2, yeah, minus -2. Be very careful. If you have a negative number, you are minusing the negative number, you'd better use the parentheses. Let's simplify a little. X minus -2 is the same with x plus 2. All right, the same thing. Please rewrite the equation we got in the slope intercept form. Yeah, same with earlier. You did the same thing twice already. This is the third time. I noticed obvious the second time you a lot better than the first time. So this is the third time. We got the equation of the line we are looking for. It's in the point slope form. Convert the point slope form to its equivalent slope intercept form. Slope intercept form is y equals mx plus b. So you need to isolate y on the left. Isolate the y on the left. Take your time. Yeah, we distribute first, right? And then we move the constant on the left over. And this one might be a little bit challenging because it has a fraction. We learned operations of fractions in chapter 1. The equation is y minus 5 equals -1 over 5 x plus 2. You want to distribute first, right? Distribute first. -1 over 5 times 2. How do you multiply two numbers? Y is a fraction. 2 is 2 over 1, right? This is a negative, right? Minus. Okay. Calculator is good at operating decimals. But my tests, the problems on my tests, the answer choices would be in fraction. What if the answer choices has no 4.6 fraction? How do you figure it out? You can look at the answer choice to convert the fraction in the answer choices to its equal to decimal, right? To see which one is 4.6. That should be okay. And it's a negative 5 minus 0.4. 5 minus 0.4. All right, let's look at it together. Y minus 5 on the left, distributive property. -1 over 5 times x. -1/5 times 2. You double 1/5. You have 2/5, right? Okay, and then you're gonna adding 5 to both sides. You have y equals -1/5x minus 2/5 plus 5. Yeah, the problem is this part. What number that is? -2/5 is a fraction. 5 is a whole number. Could we write 5 also as a fraction? -2/5 plus, could we write 5 as a fraction? 5/1, okay. And the two denominators are different, 5 and 1. What's their least common multiple? LCM. Yeah, we did spend a lot of time to understand GCF, LCM, because we use them in fractions, right? What's the least common multiple of 5 and 1? 5, very good. We want both fractions have denominators 5, right? The first fraction is already there, done. The second fraction, denominator is 1. We want it to be 5, so we multiply by 5. But we do not just multiply the denominator by 5. We have to do the same thing to the numerator. Okay, let's see what we have after this. We have -2/5 plus, what's 5 times 5? 25/5, right? Once the two fractions have the same denominators, you can keep the denominator, keep the bottom, solve the top. Solve the top. What's -2 plus 25? 23, yeah. So the fraction or the intercept in the slope-intercept form is 23/5. Yeah, that's the number. I saw some of you have the decimal. So if you are good at a decimal, I believe most of you like the decimal better because the calculator is good at operating decimals. It's still okay, yeah. But you need to know how do you choose correct A, B, C, D in the test, right? So if you see answer choice, if you see answer choices have fractions, you're gonna convert that fraction to its equivalent decimal to see which fraction is the same with your decimal. Tell me what's the equivalent decimal for 23/5. 4.6, right? Yeah, that's your decimal. Yeah. Okay, so that's the 3 examples we learned today. So far, we have covered all the 3 forms for linear equation in 2 variables. Let's make a plan for this week, okay? Let's make a plan for this week. 3.6 linear inequalities in 2 variables. Tomorrow we're going to do that. On Wednesday, we do functions. Wednesday, Thursday, we can do the review. So we plan to have the test 3 on Friday. Okay, we plan on it. All right, thank you guys for coming. I'll see you tomorrow.